So let's solve another Leetcode problem today. This time I'm solving a hard question on linked lists in Leetcode, which is called merge k sorted list. So in this example, we are giving k number of lists in a list and we need to merge them. So I have solved already a similar problem in which we were merging two sorted lists, and this is a variation of the same problem. It's just like we are given with more lists now. Before it was just two. So let's look at the problem. So it says you are given an array of k linked lists, which is named list, and each linked list is sorted in ascending order. Nice. Merge all the linked lists into a single sorted linked list and return it. Okay, fairly straightforward question, I guess, but the solution is not that straight, I would say, because if you look at this thing, how do we actually achieve this? Like there's one way of doing it that we have seen earlier in the last video, where we take one list, we take the other list. For example, let's take these two lists now, and we compare each of the node with each other node, and we basically merge them one by one, two lists at a time, and then again we merge the result list with the third list, and so on. But if you look at this, it will be leading to a quite time-taking solution, because we are iterating through every list almost twice, and that would be making it a n raised to 2 time complexity, if I'm right. So is there a better way of doing it? Let's think about this a little more. So let's see, we have this list here, and then we are merging it, let's say starting from 0, and then the first list, and then this list. Is there a way that we can solve it efficiently, also not using an extra space of having a extra merged list maintaining the result, and then again have to merge that list with the third list? Right. So since we have already seen how to merge two lists, or even if you haven't seen it, let's see how we can merge it. So for that, I'll create a new helper function here called merge, which takes the self argument, because in Python you have this first argument as self on the class methods. Then we have our L1, which would be the first list, the L2 list, which will be the second list, and then how do we merge it? So we basically create a dummy pointer, like most of the linked list based questions need to create a new list, which is not technically a new list, because we are simply pointing the existing nodes in this new list. So yeah, that's it basically. And then we obviously need to return the head of the new list, which would be pointing to the new dummy node we have created. Then we check, while we have a value for L1 and L2, we check if L1's value is less than L2. We say our dummy dot next. So if the value of L1 node is less, then we simply add it to our list, which we can do basically by doing dummy dot next is equal to L1. Also, we need to update our L1 pointer. So L1 is L1 dot next, because we need to move from the first node to the second node, and so on. But if not, that's not the case. If L1's value is not less than L2's value, and I have done a mistake here, I'll correct it. If that's not the case, we need to append the L2. Why? Because the value could be greater or equal to L1. If it's equal, then it doesn't matter which one we append. So dummy.next is equal to L2, and then we increment our L2 to point to its next node, like this. And because we want to update the new list, and we want to move forward in the new list, we need to update our dummy counter, or the pointer as well. So dummy will be pointing to the dummy.next, so we are moving ahead in the list as we are appending new nodes to the list. Also, there could be a case where we have the list of differing size. For example, in this one, 2, 6 is having length of 2, and this one is having length of 3. That means this condition won't be handling that case. So we have to add extra check. If L1 has still remaining nodes, then we simply append it to our dummy.next, which is the resultant list, which will point to L1. And it might happen that L2 is bigger instead of L1. So same thing with that one as well. We point out dummy.next is equal to L2. And in the end, we return head dot next, because our head was pointing to the start of the list, which was a dummy node. We don't want to return the dummy node, we want to return the first node, whichever we found in our case. So yeah, we simply return it. So this is basically the algorithm for merging two lists. Now we basically need to reuse this helper function to use it for k lists, which would be a slightly complex solution, but it's not that hard. I can try to explain. Yeah, so what we can do is, at a time we need to merge two lists, as we can see. So 0 and 1. Then we can merge first with the third list, as the result will be appended here. So for keeping track of this move, or this transition from 0, 2 to 3, we can introduce a variable called interval, which would be set to 1 at the start. And while we are in the last interval, for example, if our interval is less than the length of the list, we continue updating our interval. And I'll explain how that will work basically. So we have, while our interval is less than length of the list, then we need to merge the lists now. So let's say we set interval to 1, and then we need to start merging it. So at first we'll be starting with the 0th range, and then we'll be merging it with 1. So for that we can write a loop again. So for I in range of 0, which is the starting point, then we want to increment it until my length minus interval. So let's say my interval was 1, so I need to increase it until here, because that way we'll be merging this item with the last item of the node. So that's why we say list length, and actually it should be lists, not list, minus interval. And this is an interesting bit here. So every time we want to increase the value of I by not just 1 but twice the interval. Why is that? We'll have a look at that shortly. So this should be 2. So every time we increment the value of I by interval into 2. So now I have my two lists, which are basically the 0th list and the first list in my list. So what I do, self.merge lists I and lists I plus interval. So what we are basically doing here is, our interval is set to 1 at the start. So my I will be 0, which will be pointing here. Then my interval is 1. So 0 plus 1 will be pointing at here. When I come to my next iteration, my I will be increased by interval multiplied by 2. It would be 1 into 2, 2. That means my I would be pointing to this node, and then I 1 into 2 is 2. That means, yeah, it will be pointing here, and then I plus interval, which would be 2 plus 2, it will be pointing to the fourth node. Yeah, actually a bit confused here, but we'll come back to it. But for sure I know that this should be the code, right? But now we also need to replace the list item in memory. So let's just do that. So as we are updating the list, as we are merging the lists, we also are updating in our input list. See, we updated the list, and now we need to increase our interval, basically double our interval every time we continue with our while loop. So it will continue until the interval is less than 2, less than the list of the length of the list, and yeah, that's basically it. So let's try to understand what's happening here. So for that, I'll basically print I and I plus interval, just to try to understand what's happening with the interval value here. And obviously, because our last iteration would be merging the first 0th node with whatever the last node the interval is giving us. So that means our value will be lists.0, which will be the first element, which will have the merged list of all of the elements from here. Let's hope we haven't made any bugs. Yeah, and we can run that, but before that, let's try to understand how this will function. Let's run through the code. So our interval is 1 at the start. Then we have our I, which would be set to 0 at the start. Then we have our lists member, which, let's say this is our lists, right? And yeah, those are my values. We won't go into the merge because it's fairly straightforward. Right, so we went to 0. Now we enter the loop. We are starting from 0, like we say here. Then we have lists I is equal to merge list I plus interval. So that means we'll be merging list of I, which is 0, with I plus 1, which is interval. That means 0 and 1. So we are merging it and replacing the first item or ith item in the list by that value. So let's say we have replaced this item like this, 4 and 5. Yeah, that's right. Now our loop goes forward. We said we'll be incrementing the I value by interval into 2. So now our interval into 2 would be 2. So 0 plus 2 is 2. So what we are doing here is, this is my 0, 1, 2. So my second index list will be merged with I plus interval, which is still 1 now. So I plus 1 will be this plus this. So we are merging this list and replacing also, because we are putting the result value here. So I2, 4, 4, 5 and 6. Yeah, this is our merged value of the linked list. And then we continue to increment I with interval 2. That means we'll go to 4. So let's say 0, 1, 2, 3, 3, 4. So this is my list here. Plus 2, because interval is, oh actually plus 1, because our interval is 1. So we merged this and this list. So 1, 2, 3, 4 and 6. So we have replaced the value here. Now our interval will be increased by 6 again, but the value goes beyond the limit we have. So it's definitely greater than list length minus interval. So we won't be going any further. So we end our loop on the 4th. So we are coming out of the for loop, and we are basically incrementing our interval by doubling it. So our interval will become now 2. Then we have our I value, which will be back to 0 because we are redoing the loop. So this time we are going to merge I plus interval, which means the first list, which was already merged, result of first and second list, with I plus 2, which should be my third list. So this is going to be merged here. So we'll get 1, 1, 2, 3, 4, 4, and 5 and 6. Yeah, so look how we are getting the results of all the 3 lists merged in the first element now. So interval is 2. We got our result now. Then we are going to increment our I by 2. I interval multiplied by 2. So that means our I will be 4 now. So 0, 1, 2, 3, 4. So we got our list here, and we need to merge it with I plus interval, which will be I plus 2. That means this and this list will be merged. And we are replacing the ith position. So 1, 2, 3, 3, 4, 6, 10, 12, and 50. Right, so we have replaced the item, and my I value is going to get incremented by interval into 2. That means 4 intervals, which will be going far beyond the length of the list, and even this value, which is length minus the interval. So yeah, we break the loop here. Now my interval value will again get doubled, which would be 4 at this time, and my I will be back to 0. Right, so we are merging this list, which is 0th list, with I plus interval, which would be 4, because 0 plus 4 is 4. So 0, 1, 2, 3, 4. Remember how we are getting the merged list? Like, this is the final iteration of the loop, where we are merging pretty much the right side of the array with the first list, and that will replace our 0th value in the list with the merged result that we get. And this ends it because now the interval will be going to 8, which would be larger than our list length. So yeah, we get the result finally stored in list of 0. Now let's try to run it. There's a chance that I could have left some bugs in it. So let's see. Right, we did left some bug here. It says index out of range, which is interesting because this is literally the first item here. Let's interval. Actually, let's try to put a debugger because we have access to that. Oh, looks like my premium subscription ended. Interesting. Right, so that's not an option. Let's try to figure out then by ourselves. So we have interval at 1, interval is less than list. We are incrementing our I in this for loop, which is until its list length minus the interval. We are incrementing it by interval into 2, printing it, and we are merging these two lists, which is fine, and replacing it in the list in memory. Yeah, that looks fine actually. Let's 0. Let's see if there's any bug in our merging logic. So while L1 and L2, if L1's value is less than L1 L2 dot value, then we are setting the dummy dot next to L1. L1 is equal to L1 dot next. This is fine. Otherwise, we set it to L2, increment L2, and increment dummy. And if in the end I have left with anything, then I just set it as dummy dot next. And in the end, I'm returning my head, which is the start of the list. This looks okay. Oh, that's probably because if I don't have any values in the list, in that case, I need to return an empty list. Yeah, that makes sense. If not, lists return say empty list. Yeah, let's see if that fixes it. Oh, they actually need a list node. They actually, I guess they need simply a none value in this case. Yeah, that fixes it. A very basic mistake. Anyway, so it did execute successfully, and let's look at our outputs. So I'm printing the values here. Should be having actually in here. So let's say, yeah. So let's look at the final result. Yeah, so if you remember, like we forgot to put the final result of this list into this list. So yeah, it looks the same, and we can see I plus interval, I plus interval, I multiplied by 2, interval multiplied by 2 for this, for the next one, or not there, I mean here. Yeah, so this is the solution, and what's the time and space complexity for this one. So let's look at it. So we said we are dividing the input by 2, or we are basically reducing the input every time we execute a merge. That means the complexity of merging the list will be log k, because we are reducing the input size, and because we have to anyways go through all the nodes of all lists, it will be n log k. So our time complexity is n log k. This is our t, and our space complexity is interestingly constant time, which is O of 1, because we are not really using any extra space apart from having this dummy nodes, temporary nodes, which we will be getting rid of. I mean, the runtime itself gets rid of them, and we are not really using n extra space or anything like that. So yeah, that's the solution. Let's submit it. Yeah, there you go. We have successfully submitted it, and because I don't have premium anymore, it's complaining about subscription. Right. Thanks for watching. That's it for now.